This video is part of a series of interviews with some of the parachute engineers, scientists, and developers who have been responsible for the most significant and advanced parachute systems of the last half-century, and was created by the Aviation Trail Parachute Museum in Dayton, Ohio. In June 2017, at the American Institute of Aeronautics and Astronautics Forum, Charles Lowry, longtime deceleration researcher and member of the American Institute of Aeronautics and Astronautics, interviewed Ben Tutt about his work and accomplishments in the parachute industry.
Yes, it's my pleasure to sit with my longtime friend Ben Tutt. I've worked with him and he's a friend, personal friend. Ben, tell us where you were born and where do you live now?
I was born in England, southeast of England, and I now reside in Southern California.
Ben is heading up the conference, the aerodynamic deceleration part of this big AIAA forum. So we're so pleased that we're able to get you loose from all your duties to go through this. Let me ask you about your education. Where did you get your education?
My education was in the UK. I have a bachelor's degree in mechanical engineering from the University of Surrey.
Sorry. Tell us how you got into parachutes.
So my first job out of university was working for a company called Hunting Engineering. At the time, that company had the atomic weapons contract. So I was involved with modeling, simulating, designing fragmentation warheads and different types of warheads for missiles. And that was my first job in the UK. At the time, that company had a sister company in the US, and I came over in 2001 to help out for a couple of months, and 16 years later, I'm still here.
Was that sister company Irvin?
The company in the UK was Hunting Engineering, and the sister company in California was Irvin Aerospace.
Got it.
Yes.
Well, where are the main places you have worked then?
That's pretty much it. Apart from a very small tropical fish store in the UK.
Oh, yeah. You owned and ran that?
No, not at all. That was a weekend job while I was at school.
Well, tell us about the best, most memorable programs you've worked on through your career. I
like to think that they're still ahead of me, but certainly the ones that come to mind are some great stuff that we're doing at the moment with the Orion parachute system. We're also working a potential parachute for the Mars 2020 mission with NASA JPL. Also had a lot of fun and learned a lot with an airbag landing system for the Orion capsule. At one point, that was going to land on land. It was going to be a step up from the Apollo missions.
Tell me, what's the nature of your work in parachutes?
I work for a company called Airborne Systems. Was formerly Irvin Aerospace. I head up the the design analysis group there. I kind of have a broad experience and touch almost every aspect of the parachute world.
Do you enjoy hands-on work with parachutes as well as your analysis?
I do enjoy that. I tend to be not as useful with my hands as perhaps my head. Mm-hmm. But I would strongly encourage people to get a broad base and the ability to get some hands-on and some touch feel of the components that you're making really improves your design capabilities.
I've seen Ben in his job really pushing the boundaries on analysis, and in parachutes it's a very difficult and complicated thing to tackle. But Ben gets credit for so much of the advanced work that's been done that could never have been done before. So in that, what were some of your biggest challenges?
Yeah, I think to start off with, the biggest challenges were really understanding what the challenges are in our field. Um, I came from this missile fragmentation warhead kind of area where I thought that was pretty high end. And then I moved into parachutes and I thought, how hard can this be? It's some cloth and ropes. Surely everyone knows everything that's happened here. But it's a very complex physical and mathematical arena to understand what's going on with these parachutes that are packed to very high densities, and they have to rapidly inflate to many magnitudes of the size that they were packed at. It's a very challenging technical area, but from the outside, it's difficult to emphasize really just how tough it is, and people tend to think we should be a lot further ahead than we are. I think those challenges are perhaps more substantial than the actual technical challenges.
Have you been successful in what you're setting out to do?
I think in some areas, yeah. In others, maybe not so much.
Well, tell me, what tools do you use in your analysis work?
We use numerous tools. One of perhaps our favorite ones at the moment is a commercial code called LS-Dyna, and we're able to integrate some fluid solvers and some structural solvers, and to try and work out what's really going on in those interfaces between the fluid and the parachute, where both the fluid is influencing the parachute and the parachute is influencing the parachute. It's a challenging arena.
How about CFD?
CFD, we certainly do a considerable amount of CFD.
Is it useful?
I think it is useful. It has some limitations in our arena because of the large deformations that these parachutes see. Once you start approximating the parachute as a rigid body, then you lose a lot about what's inherent to a parachute.
Well, tell me about the most proudest moments in all of your career and the accomplishments that you have been able to make.
There's a few that I could probably point to. There's a parachute called the T-11 main parachute. It's used by the U.S. Army, the mass tactical assault parachute, and my team and I were able to use some of the codes that we've helped to develop and the techniques to fix a problem that parachute had in its early days. And we were able to identify the issues, propose some modifications, and then see that tested, and it worked out great.
Any others?
A lot of the proud moments I could probably trace back to working with people and trying to provide some insight into those people and watching them progress in their careers.
Well, along that line, tell us about people that you most enjoyed working with and who you most admired in your career.
The obvious one to admire is obviously yourself, Chuck. I'll leave that somewhat unsaid. I've working for Airborne Systems. We're a particularly large company within the parachute world, so I've had the good fortune to work closely with people like Robert Sinclair, Philip Delagio, and then Carl Peterson, Dean Wolf, Elsa Hennings. They're all giants within the industry. Someone that I enjoyed working with back in the early days of my career was a gentleman called John Sanders, and I think we both came into the industry at a similar time, and we were and remain good friends. But I think the competition between the two of us really pushed each other on and enabled us to make good breakthroughs in different fields.
You've had a rather continuous career. Tell us how that the way you did business in the parachute business versus how you do things today, how have you seen that change?
I think I'd point to perhaps some of the obvious things that people would jump to. Computing power has just exploded. Material science and the materials that are available to us within the industry, that's exploded to some degree. Not really close to the computational explosions, but they've both of those have enabled us to make some good steps forward.
What materials are you talking about?
When I came in, we were mainly working with nylon and Kevlar. We've been able to make some small benefits with materials like Technora and Vectran and Xylon. More recently, we've had some good success with some flexible composite material where we're able to locate fiber angles in the material at angles that are useful for the application, which has potential for some significant weight savings.
How about the biggest, most important innovations you've seen, and perhaps how you might have participated in them?
I'm not sure I could point to large innovations. There's been several small innovations that once you add them together, you can make some big breakthroughs. I've also had the fortune to work with airbag systems, and I've seen some great breakthroughs in instrumentation and the ability to understand the pressure in an airbag during a crash landing, for instance, and how we can monitor that pressure and change when an airbag may vent. There's been some good breakthroughs, obviously, other than fluid structure interaction.
What breakthroughs would you like to see most now in the near future?
I think the ability to gather test data that is particularly useful at a very good fidelity, and we really know what we're measuring, because we really need a lot of that data in order to ground or validate a lot of our models. In a lot of cases now, the ability of our models and our simulations are probably ahead of the test data that is needed to ground those models and say that these models are actually useful.
Okay, what kind of lessons has your work life taught you? Your work life.
I think that you need to throw yourself into your work, and when you're at a younger age, you perhaps have more energy to do that. I think if you can find some work that you're passionate about and aim to be productive and make a contribution, I think that you'll go far if you can find something that you really enjoy doing.
Tell us about your immediate family.
I have two fantastic kids. They're coming up to their 4th birthday very soon. And
they're twins, are they not?
They are indeed, yes. They're great fun and a lot of work, but my amazing wife, Katie, and I are blessed with these two kids.
Tell us a little bit about Katie. What is she into?
My wife, Katie, as you say, is also into engineering. She is a chief engineer for another aerospace company. And both of us working full time in technical fields, that brings some challenges to the family. But we work every day to spend as much time with our family as possible.
That gets to this question: what kind of non-work lessons has life taught you?
I think all the cliches are true, that the family comes first, and once you have a good solid base in the family, really anything's possible.
What kind of advice would you give to young engineers coming into the field these days? And I know you have plenty to work with. Young engineers.
I'd probably say push your managers and supervisors as hard as you can. I'd go back to finding something that you're passionate about, obtaining a broad base of experience and knowledge, working out which fits well with you, be humble, work as hard as you can, and things will work out for you.
We went through a number of questions here, very specific. Is there anything else you'd like to add about views on the industry itself, or anything? Views about life?
Views about life. I think there's a lot to be said for just being a good person, and applying yourself and being productive, and being a good role model for either your kids or the people that work for you.
The Aviation Trail Parachute Museum in Dayton, Ohio, tells the story of the development of the freefall parachute from its invention at Dayton's McCook Field after World War I through the vital role the parachute plays today in the decelerator industry and safely landing spacecraft. The museum includes interactive exhibits, artifacts, historic photographs, and films. Aviation Trail Incorporated has developed a self-guided tour of select aviation-related sites that are open to the public in the Dayton area. Aviation Trail's mission is to preserve and promote the Dayton area's unique aviation heritage, beginning with the invention of the airplane by Wilbur and Orville Wright. Find out more at aviationtrailinc.org.